Thank you for giving me a voice. I will be talking about pyrolysis and the method of pyrolysis to obtain from plastic and waste hydrogen. The pyrolysis is thermal or usually thermal decomposition, or in case um, thermal by heating combustion, or can be used as microwave, which is the new method because traditional is to conversion the organic matter of decomposition by breaking the carbon bonding and hydrogen obtained therefore by thermal. It usually can be used with some catalyst, if no mostly in the catalytical. And this is the aim. And in case of plastic and waste tire, which is also composite organic material, is big and huge waste. We have big ocean on oceans and sea, big plastic islands. And similarly, we have with cars, tires, which also, due to composite and more different catalyst, especially or the rest metal, are much more bigger hazard. This is caused because when plastic and or waste tire is in use, it demands some special features like strength, thermal thermal resistance, and the cannot be easily fractured. But actually, after some use, after mechanism, after some time, there needs to be replaced our most of our common using and unused or work using is landing on the landscape on or bad walls, like in case of United States of many times, also New York, was spilling the waste into ocean, which was destroying the the environment man so much. And approximately 1.1 billion of plastic is made in first 50 years. It's this growth is due to the commonness of plastic or traffic using in our daily life. The increasing society also can want to live in high levels, high level conditions, and require cars and plastics, and with this making the world. So this is the trouble to transfer the transformation to higher level without plastic. And this needs to be one of aim. But coming back, plastic was was first plastic material. For example, sample were to replace ivory in for snooker balls in 19th century. Then was coming more, and it kept to 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 make snooker more common and doesn't destroy animals. So initially it was fine, but we don't predict the consequences of so much using and didn't know what happens. Robert Thomson invited Thailand's 1846. Its first was natural rubber, but until the 1920s, it was replaced by synthetic polymers, with production of polymers and useful. Some polymers are much more properties, like semiconductivity, which is better than inorganic ones. For example, photovoltaics, inorganic silica absorb much narrower spectrum than polymer and semiconductive or conjugated polymers. And this is the trouble that is useful. So we need to carefully read limitation to what to make to prevent increase of plastic contamination in our environment. And one of aim can be pyrolysis because pyrolysis is fast. The trouble is that plastic tires are hardly by bacteria, and we need to generate so much. So we need to fast utilization, and pyrolysis is one method that even in natural in in even or even in natural circumstances is much faster than in case of natural and efficiency is much higher, but requires much more energy because it's faster and much more heat, so much reducing, so it's not so high, but still producing and generating by the composition of some hydrogen. The other trouble is, or science product is ashes, which is generated. These ashes can be perfect material for this conjugated, for example, conjugated polymers for replacing some new some conventional to plastic return up to the final discovery, the replacement way to remove this plastic in natural way, not from conventional fuel, conventional material. And ash content depends on plastic. For example, in some case, for example, polyethylene terephthalate requires after pyrolysis, thermal pyrolysis, no ashes. Why, for example, high density polyethylene, very, very 3%, what is not produced in, for example, linear low polyethylene. So we have seen the difference. The pellets difference with different type and reactor. Besides catalyst residues, ash contains cones which can provide smart polymers. Microwave assisted pyrolysis revealed even 34% of ash, while for making more shorter or chips or pellets or smaller was content where ash was only 0.1. So dependent ashes on the form also was analyzed suitable. Dark fermentation is 3 times cheaper than pyrolysis, but produce small amount of, for example, side products like ethylene, and which is necessary for polymer production. Therefore, we can obtain by pyrolysis more wider organic materials besides hydrogen. Of course, there is some ammonium of microbial electrolysis cell, but still much lower than, for example, pyrolysis. So this is pyrolysis has higher conversion rate, requiring usual changes in catalytic layer. This is the trouble of pyrolysis that requires often change of catalyst, if especially in catalytical, to be high efficiency. These catalysts are quite expensive because usually a metal oxide, and this decrease is increased risk of metal contamination. So also the, there should be produced this catalyst from waste metals, which is full in landfill. There are some other differentiation between pyrolysis and gasification, where gasification uses, in terms of the composition, also small oxygen, while pyrolysis is not. But some researchers say that gasification is also pyrolysis. The increasing is still, uh, but not so much, for example, like hydrogen for water splitting, because we have 6,000 papers in 1950 to 2022, which is lower 2 times that, for example, water splitting generation. But it is still the trouble very useful. And for example, work with different resins, where different additives or tires. For example, arsenic. Arsenic is preservative of natural rubber. So we need to strengthen, and then it is they block the composition. So we need to arsenic remove, especially to perform at the temperature of high temperature if we arsen has, because arsen is also on less of high density polyethylene ethylene sometimes surfaces because it's catalyst lower than in tires, but still. In these cases, we need to high temperature for pyrolysis to avoid occurrences of arsenic oxide, which is very toxic. So thus, in case of gasification, is not suitable because it's for sure poisoning, and thus better is pyrolysis. In case of cadmium, is thermal stabilizer of both natural and synthetic rubber, while in plastic is cadmium is catalyst in polymerization of polyvinyl chloride and pigment in polyethylene, polypropylene, and polyterephthalate. Occurs also in cable sheets and flooring. This thermal stabilizer block pyrolysis. There is need some approach for fast removal. Still, a much not very friendly, and we have big trouble. And maybe by absorption or something like some catalytic will be the solution to prepare the waste. Other is chlorine, which supports polymerization of synthetic rubber, and that's waste in waste tire, while in case of other polymers also support polymerization, so also in every polymer is quite on surface occurring. and block decomposition, so it needs to be removed before the process. The other compound is lead, which is stabilizer of rubber in tire production. In case of polyvinyl chloride and low density polyethylene is used as heat stabilizer. So heat stabilizer slows down the pyrolysis does need to be removed early. And other very trouble is mercury, which is stabilizer in synthetic rubber for tires and high in vacuum cleaner bags for polyphenol chloride. The trouble is that stabilizer slow pyrolysis and additionally the catalyst for pyrolytic catalytic is likely to be poison. So this is the big trouble also. Nickel is also stabilizing slowly, so it's catalyst in tire production and stabilizer in production of polypropylene. In case of antimonium, is stabilizer in rubber of steel and styrene in tire production, and is catalyst in PET fibers. And this stabilizer not so well, but slow down the pyrolysis also. There's pyrolysis contains steam much more less toxic. That's gasification, which is less more stabilizer and less selective for silane and toluene conversion, producing more ash. If we use they found sometimes that if they use some catalyst, the remove of emission is also used, so some additional catalysts are fine to be replaced. Others contain other is the which are reactors. So mostly popular reactor for pyrolysis of waste tire and plastic are fixed bed reactor, fluidized bed reactor, conical stacked bed, microwave, auger, rotary ablative, and coolant. The fixed bed reactor is suitable for pyrolysis. Simply design a high hydraulic retention time, low heat transfer. Optimal for temperature for biased tires, for example, is 400 Celsius. And in case of plastic, fixed bed reactor is very well for production nanoparticle from polyvinyl chloride and high density polyethylene air. So this is used, and in case of fluidized bagged reactor, is fast fine for fast pyrolysis in slow 1 to 5 seconds. Enhances oily, high investment design cost and operation cost. And flow, nitrogen, is deduction solved, vacuum product distribution in case of plastic. And in case of microwave, is promycin and effective heat transfer to plastic waste. In waste tire is good for production of absorbent carbon black and enhanced heat transfer under isothermal conditions. This is the most important, and these uh, processes are different. So, in case microwave assisted, it increased to produce low ash, especially on for polypropylene and high density polyethylene. So is waste because less ashes if we want to know ashes produced. Other contaminant or other problem are catalytic pyrolysis is using, and this is the how often used, and the feed carbohydrate rich and for the lignocellulose and plastic waste is more needed. Plastic is more fit, liquid, more more faster. Uh, it needs use kata surface uh, of average and temperature, fairness, and this is flowing surrounding. Why, in case, for example, catalyst is better to use the powers which also all potential all surface reaction. It's better. So this is the comparison of these two materials. Why, in case in case in case then is in case of for example, comparison of dark fermentation is is much lower efficiency, and in case of this dark fermentation, the catalyst are this bacteria, while in case of bacteria, for example, bed with some packing on catalyst, which replace this enzyme because in bacteria case. We have several kinds of pyrolytic oil, range 400. If we want to produce heavy alkane, in case of we want to hydrogen, we use simply 400, 600, so the range up where the 600 we use more gases product, and we see that so there are several types. It's catalytical clarification, so only 100 to 300, which is good for bio-oil production beside monoid hydrogen. Catalytical, which is good for fuel and bottom benzene tolerant cylinder production. There are also flash, is good for fuels, microwave, ultrasonic using ultrasound, which using of nanobacteria better, and is slow pyrolysis, which is more suitable for recover monomers and make something other. So this is the several points, and the future is that we can be useful pyrolysis to produce some polymers, especially in hydrogen, in a faster way, but still would be supporting would be bioprocesses, but not in case of our generation. In some many situations, pyrolysis would be better. So thank you very much for listening to me.